Azizah is an ITB-trained chemistry tutor for Cambridge, IB, and international learners. Details in the description.
Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone. Let me introduce myself. My name is Azizah Nabilah Putri Setiawan and you can call me Azizah. So today we are going to see the material about acid-base equilibrium in aqueous solution. First of all, I was talking about the phase. Okay. So this is the basic concept of aqueous solution. If we're talking about aqueous solution, we already know there is a two component. Component is solute and also solvent. Okay. So what is the difference about solute and solvent? Solute is, I would say, example, probably NaCl, KOH, etc. And solvent, probably like benzene and water, and etc. Okay. For the specific in this topic, we make solvent as water. Okay, so the equilibrium of water can ionize like it. Okay, why the phase of H2O is liquid? Because they are solvent. Okay, so in equilibrium phase, H plus equals plus OH minus. And then we know that the general properties of equilibrium, which I just want to mention Kc, Kp, etc. We know that the equation of this is the concentration of product, the power of coefficient, and then divided by concentration of reactant divided by coefficient. Okay, so we put this equation into the same with H2O and K. Why Kw? Because in this form is water. It makes it a little bit different with Kc and Kp. So Kw is actually equal to concentrate of product, the power of coefficient, and then to reactant, the power of coefficient. Okay, so this is the notes of in the general properties of equilibrium. Yes, we have to already thinking about the phase. Okay, so there is a little bit different when the compound phase is come to the solid and liquid. In the thermodynamics, we know like solid and liquid is really stable. So the concentration of their phase is equal to 1. Because of that, this is aqueous, and this is liquid. So in the liquid phase, we just make it 1, okay? With the aqueous phase, we can calculate like this, okay? Divide the power of 1 because the coefficient is 1, and then OH means 1. This is also aqueous. H2O liquid, we can input 1 into the equation. We already know that Kw is equal to 10 the power of 14. Because of that, we have 10 the power of minus 14 equal to H plus and then the OH minus. Okay, I want to make it with. Okay, after we know that the equation with the equilibrium of water, and then how about, okay, so this is the interview question has, how about acid and base? Water is neutral, we know, because the pH of water, the pH of water equal to 7. How about acid and base? The idea is how to calculate pH acid and pH base. So we already know the concept of pH. I want to say like this is the word and this is okay. The concept of pH is P for how many H plus ionized in solution. Okay. A pH, we calculate pH equal to minus log H plus. Okay. Sorry. Wait. Okay. And we calculate PLOH equal to minus log OH minus. Make it. And pH plus POH equal to 14 because this is actually anti-log. So this is just 10 the power of minus 14 is actually anti-log of 14. So in this part, we calculate like pH plus POH equal to 14. Okay. This is the basic concept I wanted to talk about the acid-base equilibrium in aqueous solution. So you have to be remember that 10 the power of minus 14 is equal to H plus to OH minus, and then pH and POH, and when they're combined to be 14. And the second part is we want to know how to calculate pH, but we know that we have acid and we have base. So there is a different concept about calculate pH when the properties come to acid and the base. Acid is actually have two properties: strong acid, okay, and a weak acid. Also with the base, strong base and then weak base. If we wanted to know the differences about the strong acid, strong base, probably in the another chapter we call like the general acid and base, and probably with Lewis, Bronsted-Lowry, etc. We just focus on how to calculate pH in the four forms of properties. Okay, first of all is strong acid. Okay, strong acid. Why we call I wanted to make it with example, probably HCl. Why we call HCl strong acid? Because the alpha 100%. It is probably like, okay, what is alpha? Alpha is the percent of ionization. So the 100% HCl, okay, aqueous, or BH plus Cl minus. So if I wanted to look at with ICE, okay, probably really familiar. I is initial, is change, and this is equilibrium or equilibrium. Okay, so if I just make an example, it's this one and it's also one and it's zero. This is when we call 100% of ionization, because alpha is the concentration in the change divided by concentration in the initial. So 1 equal to 1%. Okay, this is why we call strong acid is alpha 100%. The perfect of ionization. How we calculate pH? The idea that I talked before is pH, okay, is minus log H plus. Okay, you must be careful in this part. Okay, I wanted to make it with the rate. Okay, careful. Why? Because H plus in the form of pH is half to in molarity. Okay, you must be careful to read in the question. They give you with the mole or with the molarity. You have to put this into molarity unit. Okay, molarity unit means mole divided volume liter. So there is a lot of mistakes because you probably miss this part. Like, okay, so volume, the volume in milliliter. You have to convert milliliter to liter first, and then calculate this before you input in this equation. You have to be careful for that. If I talk, this is 1 molarity. Okay. Okay. So the H plus will be 1. So minus log 1 like this, and you can calculate in calculator, or probably this is also an answer in the question. Okay, but if we have weak acid, okay, if we have weak acid, there is a difference when you have a weak acid and then strong acid. So you probably wondering like, how do I know that? Like, okay, so HCl we know, okay, the alpha is 100%, but we already know about another acid. Okay, so I wanted to make an example with wait, I think I have to clear this out to make it really clear. Okay, weak acid. There is the key that you have to remember in the question. They give you EA. Okay, so probably they give you EA. I want to make it example CH3COO. We call it acetate acid. You don't have to familiar about acetate acid properties physically, no. But if you look at, there is a Ka, because CH really similar with W is like water, and E for acid. H means acid, W means water. So if you have Ka in the question, okay, this is the weak acid. This is the sign. You cannot to put the equation like the strong acid. No, you cannot. So how do you know? How do you do? Is Bronsted-Lowry balance. Okay, Bronsted-Lowry balance. You have to remember that weak acid, you cannot just, okay, so it's simple like CH3COOH, so equal to H plus CH3COO minus. No, because the alpha below 100%. He doesn't know about the alpha, right? But we have pH. It cannot to be like this. No, okay? We have to be calculate first with H2O. Okay, this is so different. This is aqueous, this is liquid. In the Bronsted-Lowry concept, probably in the another chapter, is the H plus from acid, okay, from acid, yeah, is transferred to the H2O. So because of that, H is transferred to the CH3COO minus, because one of H moved to H2O, and then after that H3O, because H come to this, and then aqueous. Why we cannot do with this? Why we have to do for this? Because they're weak acid, they have PA, they use Bronsted-Lowry balance concept. It's different, and we call H3O similar, with H1. The form is a little bit different, but in the same meaning. H3O equal to H4. But we have PA, so if we put this on the ICE again, okay, I want to make it clear in this part. Okay, if I have this probably 0.1 molarity, okay, it cannot be 0 in here. No. Why? Because of weak acid. So So we have to make it with X. It's a little bit hard. That's another part. And then like this. So H2O, we doesn't know about the concentration of water. You can remove the H2O on your focus because we already know in theory like this. The H2O equal to 1 because the phase in the liquid. So we just put it like the blank. It's okay. So in the initial, of course, the product hasn't been here. So in the C, if this minus X is equal to plus X, and then this plus X and plus. This is the how Ka doing for this equation because we need Ka for this. We doesn't know even X is. Okay, if we have the exact alpha, probably we can have the X. But if we didn't have the alpha, we have to use Ka. So Ka, same concept with the general equilibrium, is the product to the power of hydrogen plus divided to concentrate of reactant divide the power of hydrogen. But it's a little bit different. Look at the balance. This the product, right? Okay, but this is the reactant. Have to remember this, not put this into equation. So product will be CH3COO minus and H3O plus divided to CH3COO, and you don't put H2O because equal to 1 because their phase is liquid. Liquid and solid are always 1. So put this into equation. We have X min X. Okay. I would say, okay, this is another example like pH is 10 the power of minus 5. Okay. So it's equal to power of minus. If you have a calculator, you probably can calculate really easy. Okay, you have to X. But if you cannot use the calculator on your task, okay, yes, you probably like make it this. So sorry, X to the 10. Okay, oh, sorry. Okay, but if you look at is 10 minus 6 and then minus 10, right? It's really a small number, so we can think that it's negligible. So okay, we can put the assumption like X is equal to, because this is really small, so we can see that it's negligible. We can also make it. So after that, if we just line it out like X quadrat per 0.1 equal to, easy calculate, right? And then this is why in the weak acid we have H is a concentration. I would say is for acid, right? And then you can call pH minus log H4. Okay. If I wanted to make a summary, please remember if you have the alpha not 100% and then PA on the question, please thinking that it's not strong acid, it's weak acid. So you have to be balance their form to be Bronsted-Lowry concept and then make it this equation. It's really different when you have strong acid. You just put pH, H, and you can put this into equation. No, it cannot be easy. But please careful and look at the equation really good. Okay. I'm sorry. I'll probably 2. Okay. And the 3 and 4 we call about the base. It's actually same concept but in the form of the OH compound. Okay. So I wanted to make it clear to another chapter. Okay. If we have a strong base, okay, 3, and we have the 4 is a weak base, it's really similar with the acid. The difference is we have OH, like, okay, I would say strong base with KOH, probably weak base, I would say NH3, and KB is really the same. Before we call Ka, and this is we call Kb because this is base. Okay, I will say 10 to the power of minus 5. Okay, because of strong base, the concept is really same. Alpha 100%. So what happened? KOH equal to K plus OH. Really simple. But if you have the weak base, we have to make it a balanced equation with Bronsted-Lowry concept. Okay, Na3 equal to N2O first, and then this is a little bit tricky. You have to remember that in the Bronsted-Lowry we have to remove H plus from acid to base. Yeah, but in the weak base we have base. We don't have acid. So as H2O will be acid in this equation. So H plus from H2O move to NH3 to count NH4 plus to remove, so HO minus. It's really similar to OH, right? So we can go from this. We're really familiar about it. Really same. Okay. If we have the strong base, the alpha 100%, so it's actually the same. I didn't have to put the ICA, right? Yes, you can just like this. Okay. The coefficient is same, so okay. And you can called, okay, you wanted to calculate pH because it's not convenient to calculate pOH in the commercial, in the industry, in the question, because we didn't need that this format. Okay, we didn't need this. Yeah, okay, we just need pH, but we didn't have H plus, right? Okay, well, no. So the idea is how to convert OH min to the H plus. You have two ways for this problem. Okay, way one. Okay, we can use KW. KW. I'm sorry, is H plus OH minus equal to 10 to the power of minus 1. If we have OH min, we can calculate H plus, right? H plus 10 to the minus 14. So we can calculate H plus 5. Okay, simple. So after that, we can calculate pH. It's really easy. But we have another way. Okay, way two is, how about we calculate pOH? So pOH minus log OH minus, so equal to minus log, equal to 1, and then pH 14 minus pOH. 14 minus 1 is equal to 30. It's actually the same. If we put this, it's also the same. It's similar. So it's up to you. Wanted to do it Y1 or Y2. It's not a big deal. But we have a weak base. You have to create with ICA. I just recommend this one. But okay, if you don't have a lot of time, okay, wait. I wanted to make it this. Okay, this minus X plus X plus X. So, oh my God, I think it really takes a lot of time of you if you on the UTBK or something. Probably it's really needed time. So I suggest you to direct use the equation of like this. Okay. Okay. But in for exit, so for base, we can have OH minus equal to KB and base. We can put this direct into this, and we have OH min. So after that, you can move with this one. pOH equal to minus log OH min. So if I want to make an example like 3 and to the power of 5, 8, and to the power 6, okay, and then pOH minus log equal to 3. And pH, don't forget, we don't need pOH. I always say to you, is we just need pH. So 14 minus 3 is 11. So see, in the same of concentration, in the same of concentration, with a strong base, we have to pH 13. In the weak base, we have 11. Yeah, this is the way a strong base and a weak base is different. Okay, we have the third part is titration. Okay. So the titration is when you combine acid with base, form to salt and water. Okay, because of acid has two properties, is also base. We have strong acid and then weak acid. Base is strong base, weak base. Okay, the titration has a more different. If we combine strong acid with strong base, it's different. If with weak acid to the strong base, and vice versa, if we combine weak acid to the strong base and weak acid to weak, it's different. I wanted to make it one example to make it all the process of titration is. So titration basically if this or just like this. Okay, the curve of titration with pH, this is pH, and the volume of, I would say, is base, and this is the volume of NK. So there is 4 points we have to look at more deeply. So first this, second with this part, third the equivalent point, and for after atau past equivalent point. I will go with this as an example. So with this, what called CH3 COOH equal to plus base with TOH. Okay. To make it the equation balance, you have to ionize first the two of compound in this equation. This will be H plus, and then CH3 COO minus, and this K plus OH minus. And you have to shift them. Plus this you combine with minus K, and minus this you combine with K plus. So H plus OH min equal to H2O, and then this equal to KCH3COO. Okay. It's from aqueous liquid. Aqueous. We go with this to the curve and the 4 point of this titration curve. Okay. First of all, if the titration not started, like you just put the Alan Mayer. So this is Alan Mayer, and you have Buret. This is Alan Mayer, and this is Buret. Before you put the base into the Alan Mayer, in the Alan Mayer just acid. Okay. So because of that, pH in the point 1, so point 1 is just acid. Okay, because not base put in the Alan Mayer at this point. Okay, because of just acid, we just look at careful of properties of acid. Okay, CH3COOH. So this is weak acid. Okay, weak acid. So H plus is equal to Ka. Okay, I wanted to make it clear that if you have alpha, okay, you don't have Ka on the question, you just have alpha, you can also calculate with this equation. Okay, so you can put just alpha and then the concentration also for acid. Okay, if this acid is 0 point molar, and then pH also same, so if actually with this equation we have H plus 10 to the minus 5 A and to the minus 6. So okay, we have pH like 3. Okay, the titration start, so we put the base 1 by 1 to the Allen-Mayer, and then the pH increase. But in the point 2, okay, wait. Okay, the point 2 titration start, okay, but not the equivalent point reach up. But with this point we call a buffer. Why? Because if we put this calculate into this CH3COOH plus H2O, COH H2O plus IDA. Before equivalent point, always there is the acid in the Allen-Mayer. So in the equilibrium stage, probably if we have 10 and this is 5, okay. This is just example. This is minus 5. I'm sorry. 505. Okay. So there is left of acid in the equilibrium and weak acid. The key is there is left of acid or base. We can do for both of them, but weak. The properties have to weak. Because of weak acid or weak base, we can this as buffer. So there is probably another question. If in this part is not weak acid, probably the strong acid or strong base, it would be different. So buffer have to be in the equal is weak acid or weak base. It's really the key. But okay, sometimes we have the volume on the question in the milliliter unit. So probably we have molar with okay, kind of something like this. We can calculate the mole. Okay, so in the IC of the buffer section, we have to calculate with mole, but we also can calculate with millimole. So the NCH3COOH, okay, to this, okay, like this, right? We can put to convert milliliters to liters, but it's like milliliter, 5 liter, 3 liter. So we have wait, I think just wait. Okay, is okay. But we can also calculate with millimole. So it will be like this. Okay, I'm sorry. It's like 10 millimole. Okay, so it also can be to put this to the equation. It would be fine. You can convert first milliliters to liter. It's accepted, but you can put this into millimole. It's also not a problem. So this is millimole. It's okay. It's not a problem. Okay. After all, what is the pH or pOH we can have for this condition is a little bit different. Okay, pH, that is another equation, pKa. Why? Because the acid weight plus log, we can put with N, it's okay, mole of the salt, wanted to make it general, and then mole with the acid in the equation after the reaction. Okay, so this is the pH. And this is the pOH. It's also pKb plus log mole salt divided to mole of base. This is the for buffer solution. We can move with the point 3. So point 3 is equivalent point. Okay, wait. Equivalent point. Okay, I call it like IIV in this. So equivalent point means the base and acid fully react. Okay. So the difference is, okay, I wanted to put it same. No. Okay. If in the equivalent point we have exactly the same of acid and base, so in the equilibrium is 0. This is the sign that we call, okay, in the equivalent point. Okay. So how calculate pH in this stage is we just have H2O and then the salt. So the idea to calculate pH from the salt. Okay. There is a tree of properties: salt, acid, salt, base, salt, of course, neutral. Okay. We have acid salt if we combine weak base with strong acid. We have the base salt if we weak acid plus strong base. Look at this. The sum of the properties acid or base also imply to the salt therefore. Neutral too can be strong acid, strong base, also can weak acid and weak base. We have to look at the more. This one, CH3COOK. But we already know that this is weak acid. Okay, so weak acid equal to this is strong base. So this is will be base salt. Okay, so there is a difference. If we have a base salt, we can calculate with the equation. Okay, I want to make it like this. Acid salt. If we have acid salt, so H plus equal to Kw. We use it in this form with Kb equal to concentrate of salt, of course. Okay, but if we have a base salt, okay, so H minus salt. Okay, so for this example, we have a base salt, so we calculate OH minus first. After that, we can call the OH and then pH. Okay, but if we have the natural salt, okay, if we have the natural salt with acid, strong acid plus a strong base. Okay, so the pH probably natural, right? Yes, so natural, so probably can 7. But if we have this weak acid, also weak base, we have to look at more with PA and Kb, because probably there is a differences about the number of them. We have to be more careful about that. But for most of the question I found either acid salt or base salt, so you have to read a little bit more careful about the properties of base and weak at the same point. But so after equivalent point, so after this we have this stage. What is happen? Okay, point 4, path of equivalent point. In the titration, we have the indicator. You probably see in this Allen Mayer, there is a change of the color. So first of all, probably the color is pink, and then after that it turns to yellow or it turns to blue. So with the a little bit of base and there is a change of the color, because okay, it's up. The titration is up, and because of if we turn out the base after and after, this is in the phase of state 4. So if this equation, sorry, IVKOO, this is IVA. Okay. In the fourth point, this is the probably 20. This is the difference. So there is a base, okay, on the equilibrium, but the weak acid is already gone. So in this part, we have to calculate PA to the basic concept. We have to look at them more carefully. KOH is strong base. Okay, so the strong base is not calculated by the point of 3 or the point of 2, but it's also calculated by KOH. Okay, basic concept ionized to be K plus OH minus. It's back to if we have 10. I would say this is a 10 millimole. So we have OH like 10 millimole. We didn't have to calculate with this. No. Why we didn't calculate with this? Because KOH is strong base, not weak base. So OH we like 10 millimole with the volume. Okay, so this is the volume. Okay, I wanted to say like you have to be careful in this part, okay? Because this is what CH3COOH also has a volume. I would say milliliter. Okay, KOH also have a volume. Okay. To the calculation in this stage, you have to put them together. So 10 millimole equal to this volume and this volume because they're in the Allen Mayer together. So this is 100 milli plus 100 milli. That's 10 equal to 100. Okay, so you have to OH mean, so you can calculate the OH. So after that, you can call pH 14 minus OH. That's it. So I wanted to make it a summary about the titration. So first is the initial stage, probably just weak acid, or it also can can be with a strong acid. So you have to calculate pH in the basic concept of them. But when the titration starts, okay, we can call it the buffer stage. Yeah. So the acid or the solute in the element field there, but it's also reacted with the base into the salt, a few of them, but not all of them, just few of them. And then we have to equivalent point or the three, and then sometimes we call is hydrolysis. Yeah, but it actually happened in the equivalent point. We just looking the salt, and then after all the pass of titration, we can calculate to the basic concept again. So if you have the titration, the acid combined with base, first of all look at the properties, if the acid strong or weak, the base strong or weak, and then look at really more carefully in the phase of the titration, or is it 1, 2, 3, or 4, because there is a differences of using equation in every part of the titration. I think this is the all of the acid-base aquarium and aqua solution. If you wanted to ask more, and you can call to the comment below in the video. And after this, we can make an example with the question. This is the question 1. So we have acetic acid, CaCOOH is 75 milliliter, 0.1 molar, and then with NaOH 0.1. Okay, so A pH before NaOH F. Okay, so we have to understand that the properties of CaCOOH is weak acid. This is why we have Ka equal to 10 to the minus the power of -5. And then pH before NaOH is just acetic acid. So because of acetic acid weak, we have the equation like this: KaM 10 to the -5 and times 0.1 and 6 to the 10 minus. Okay, after that we can calculate pH minus log like this. We have to understand that this is one time. Okay, so we put 3 into the like this. Okay, so is plus 3 plus 0, so 3. So pH before NaOH is 3. Okay, we move to the B. So B is the pH after. Okay, B pH after 25 milli of NaOH. Okay, we have to make it balance first with CH3COOH plus NaOH. Okay, if you not familiar, you have to ionize them, so it can be with this plus, and then CH3COO minus. This will be Na plus, OH minus. Make them shift plus with the minus and the plus with the minus. Okay, this combined with this, so is H2O plus, H2O plus NaCH3COO. Okay. We go with ICA. Okay, so remember with the ICA in this situation, you have to use mole. As I said before, you can use mole or millimole. It's also accepted. I think we go with millimole. So we calculate this mole of CH3COOH 75 times 70 millimole. Okay, we put this. Okay, and NaOH we can see that 25 milli. So N of NaOH would be 25 times the concentration, so 2.5 millimole. 2.5 millimole. Okay, in the initial, the product hasn't been formed. This is the tricky. So in the change, we have to look at more with two values, lower value. So the lower from the 7.5 to 2.5 is 2.5. So we put this minus 2.5 minus 2.5 plus 2.5 plus 2.5. Why this is minus and why this is plus? Because in the reaction, the reactant always decrease and the product always increase. So this is the why is from to minus, and this is plus and the plus. After all, we calculate this with 5 millimole, 0. 5 millimole, 5 millimole. Okay, I want to clear. Okay, this is the point. Okay, we see this. There is a left of CH3COOH, but this is weak acid. So it's actually the 2 point. It's equal to buffer stage. Okay, if the buffer stage, we have to look at this as the acid. So we can calculate with equation After we know that in the equilibrium we have the weak acid left, and then it's for the salt. So this is salt and this is the weak acid. So if we combine them, so we have buffer acid. Okay. In the previous introduction, I said that to calculate buffer acid we have pH, pKa plus log mole acid per mole salt. Okay. But to make it the equations simple, we can just calculate H plus as the buffer acid to Ka acid with salt. Okay, we have pH 10 to the power of minus 5, acid we have 5, and then we have salt 2. Like this, we have pH minus log 5 minus log 2 as a pH. Okay, we move to the C. After half of half of the acetic acid has been neutralized, so we move to the C. Okay, we move forward to the C. So C, we have after half of CH3COOH, so we can make it the balance CH3COOH plus NaOH 2 plus H2O. Okay, initial change equilibrium, and then we can calculate pH after half of this. So half this probably 25 to 7.5 milliliters. So the mole will be 7.5 millimole, and then for the I'm sorry, this is 75. This is okay. So there is the half in the equation. So NaOH we use is actually the same with this. So 375, 3.5, 5 is 0. The condition similar to the previous before because there is weak acid and this is salt. So it will be buffer acid. Okay, buffer acid we can use the same equation H plus equal to PA acid with salt. And acid this and salt this. So it's equal to 1. So equal is 10 to the power of minus 5. So pH is min log 10 to the 10. So pH is equal to 5. The last we have D. D is pH at the equivalent point. Okay. Equivalent point means there is no KSOH at the end. So if we form to the equation balance, we have its initial change, and so if we have like 7.5, so it's 0 in this equivalent point. So also we have NOH like this. Okay. Because of there's no in the M, we call it hydrolysis or equivalent point. Okay, we have to look at the salt. This is the salt. Okay, what the properties? CH3, CH3COO, and H comes from weak acid and the strong base. So the properties of CH3COO and R will be base salt. Okay. Base salt we can calculate with OH minus equal to KV per Ka to salt. KV minus 10 to the minus 5 equal to 7.5. Okay, but we have to careful to look at the volume because this is the total volume, and then so 75 equals plus 75 plus 75. Okay, because the total, and then after this we calculate this to this, so equal to 511, and then minus 7.5. Okay, so this is will be 5. We can calculate POH. So POH will be minus log 5.5 is equal to minus, and then 5.5 log log 5. But is this just POH? We have to calculate pH. Okay, I will be delete this section. Okay, so pH equal to 14 minus 5 minus log 5 plus log 5. Okay, so we're moving forward to question 2. We have to calculate the percentage ionization of alpha. Okay, so alpha can calculate easy with the equation of, okay, we have acetic acid with the 3 different molarities. First is 1 molar, and then second is 0.1 molar, and the third is 0.01 molar. With the same equation, we actually can calculate alpha equal to pH per 1. This is pH per 0.1, and then pH with 0.01. And we already know in the question pH equal to 10 to the power of minus 5. So this will be minus 5, and this will be 10 minus 5, this, and this will be like this. So this is okay, I just wanted to make it this just approximate. Yes, it's actually like probably 10 to the 5, and then this probably 6, and this probably I'm sorry, 4. This is 3. Okay, and this, if we wanted to make it a percentage, we probably go with 100%. So 3%, we like this. So it 1%, probably like 0.3%. And then we already know that if the concentration decrease, so it also impact to the percentage ionization. So when the concentration increase, the alpha O would be increased too. Okay, we will moving forward to next question. Okay, the last question is question 3. Okay, it's a different when the one and question 2. We have to calculate the volume of NaOH if the concentration of NaOH is 0.1 molarity. Added with the HCl concentration 0.01, and then the volume 2 liter. Okay, and we already know the pH equal to 3. Okay, this is the tricky one. So pH equal to 3 is actually below to 7. So if you acid, we have the fact that, okay, so probably in the end of the equation would be HCl, and then we can make the balance OH plus HCl equal to NaCl plus H2O. Initial change equilibrium or M. So initial, we have to calculate the molality of NaOH. So the N of NaOH would be delivered by the equation P times molarity. But we don't have the volume. We need to know the volume in the answer sheet. So I have an idea to, it's okay, we can put P and then time to 0.1 molarity of NaOH. So we put this like this. Okay, HCl, we know the volume and the concentration, so we can calculate the mole of HCl. So it's equal to volume 0.2 times 0.01 mole. So it would be 2 times 10 to the power of minus 3 mole. So it's like 2 to the power of initial, no product. In the change, so it's tricky because we already have pH we want to in the end of this equation balance. So we have to work with this pH. Okay, it's actually minus log H. If we have pH 3, okay, we can have H plus. It's anti-log of the 3. So it is 10 to the power of minus 3. Because if we come back, so it's 3 minus log 1. So it's equal to 3. So this is molarity. So H plus is mole divided by P total. Okay, mole, we got this. And the mole, okay, P total. We already know the P of HCl, but we doesn't know the P of NaOH. So we have to calculate this by plus. Okay, we doesn't know the volume yet. Okay, mole and minus 3 equal to P. Okay, after we know all of the mole in NaOH and HCl. Okay, but in the end of the equation, we just have HCl because the pH is equal to 3, so we probably would go with it. So it's equal to 0, and this and this okay, so this will be 2 minus, so it's probably like a little bit complicated because it's for liters, but it's okay, we can complete this. So it will be with mole, right? This is mole, and we also have this. We combine two equations to this equal to, okay, the idea we can move the equation to get the V. Okay, this to 5 dB, and we go with this, okay, so can move V this to the, okay, so we got a V is just estimated by just in 0.15. But it's liter, so if we wanted to make it with millimeters, we can go with 17.8 milliliters. So if you think that it's too complicated to this, you can to moving forward to the milliliters, probably can be easier. I just use this because in the question we already have the liter. But if you okay, it's too complicated and I wanted to go it with milliliters, so it's up to you. It's really okay to choose something else. But this is the question a little bit different rather than this. We have already volume, already concentration. It's different. So to summary all of the question, I give you three as an example. Please be calm and then read carefully about what they're looking for. So after this, I think you're gonna be fine. And this is thank you for me. So with this asset-based aquarium in Aqueous Solution, I hope you understand well. If you have already a question, you can put it on the comments or you can put it to admin to asking, and then hopefully I can see you on the private session and see you on the next topic. Thank you. Have a nice day.
Thank you for learning with BimbelQ. We support clear and structured understanding.